Hey guys, welcome all, and today we are going to learn about phase diagram, that is iron carbide phase diagram. This is one of the important topic when it comes to any competitive exam because every year you may expect at least one question from this phase diagram. And moreover, we have different explanations on phase diagram, how to understand phase diagram, how to learn or how to simply mug up phase diagram, and so on. Today, we will understand this phase diagram with a very different perspective. I have divided this lecture into two parts. In first part, I will give you a very funny example so that you can relate that example with your phase diagram. I know this example may not be 100% perfect here, but this example will help you to digest what actually we are trying to understand from this phase diagram, or what actually we are going to learn from this phase diagram. Simply, what is the use of this phase diagram? If you want to understand any topic, say any difficult topic or any complex topic, try to slice down that topic into several parts till it become a common sense. And when that particular concept is at your common sense level, then you will enjoy that concept. It will be very easy to understand, to learn that particular concept. So let's start. So what actually we are doing here, try to understand, guys. This is our iron as our base, okay, and this is carbon, okay. So what we are doing, we are adding this carbon into iron, different percentage of carbon at different temperature, we will have different phases, okay, and that exactly what we are trying to understand from this phase diagram. I will give you a funny example. I know this example is not 100% perfect here, but this example you will try, as I already said, this example will try to understand the things in better way, okay. So as we know, pizza is our favorite dish, isn't it? So I will try to relate this pizza with our phase diagram. Listen carefully. Assume this iron as our pizza base and this carbon as our toppings, okay. So what exactly we are trying to understand from this? Toppings as in, say, onion, so say tomatoes, say black olive, say capsicum, and so on, say mushroom also, cheese also, okay, even non-veg pizzas also. So what exactly we are trying to do, if you add onion on your pizza base, so it will be onion pizza. If you are adding tomatoes, so it will be tomato pizza. If you are adding both, then it is onion tomato pizza. If you add everything, then it will be veg overloaded pizza. If you add extra cheese, it will be cheese burst pizza, and so on. So what exactly we are trying to understand from this point, that with different percentage of toppings on this pizza base at different temperature, okay, temperature is also important, because if you bake or whatever your pizza at 100 degrees Celsius, you will have different taste. If you cook your pizza at 200 degrees Celsius, your cheese will melt properly, so taste will be different. So what exactly I am trying to say here, that with different percentage of toppings on pizza base at different temperature, you will have different pizzas. Similarly, with different percentage of carbon in iron at different temperature, you will have different phases of iron and iron carbide. If at X percentage of carbon and Y degree Celsius, you will have austenite. Say if at X percentage of carbon and different Y degree Celsius, you may find cementite, you may find austenite, you will find ferrite, you may find perlite, ledeburite, and so on. And what are the reactions also occurring at different percentage of carbon in our phase diagram? Say eutectic reaction, eutectoid reaction, or peritectic reaction. These are very important reactions that we are going to understand in our further explanation. So now we will understand exactly how these phases are occurring in iron carbide phase diagram. Okay, so on x-axis we have percentage of carbon, and kindly note this is percentage of carbon by weight. This is the important point, many times asked in exam. And on y-axis we have temperature. Again, kindly note this temperature is in degrees Celsius. In this phase diagram we have different regions, and in different regions we may find different phases of iron carbon. So if you notice carefully, this is the region where you will find alpha ion, that is alpha ferrite. This is alpha ferrite. Similarly, in this triangular region, if you notice carefully, we will find delta ion. So this is the region of delta ion. At the same time, this entire portion, this is open portion, you will find liquid phase. Okay, and this is the region, this is the region where you will find austenite. If you notice carefully, if it is delta ion and if it is liquid, so this intermediate region, you will have delta plus liquid. Okay, and if you go by this, you will have this intermediate region where liquid plus austenite phase will be there. Okay, similarly in this region you may find delta plus austenite. Okay, similarly here it is alpha plus austenite, right? If you go by this, similarly you will find here liquid plus cementite, isn't it? So these are the different regions where you will find different phases, right? Okay, now the most important part, that is how to learn the changes in phases, and later we will understand how exactly the reactions, that is transformation reactions, are occurring in this phase diagram. Transformation reactions, I mean eutectic reaction, eutectoid reaction, and peritectic reaction. So we will understand in detail. You just listen carefully and try to understand each and every point precisely. Okay, so I will take this example, this complex diagram. I will show this diagram here and try to understand this first carefully. So if I draw this a triangular portion here, okay, so this was our triangular portion, right? Okay, now at particular or at fixed percentage of carbon, we will understand what are the different phases we will get at different temperature. And how to understand this, listen carefully. I will just take a vertical line here. I will just draw a vertical line here. Okay, similarly I will just draw a vertical line here, right? Fine, this is point number 1, this is point number 2, this is point number 3, and this is point number 4, right? Similarly this is point number 1, point number 2, point number 3, this is point number 4. I will mention these 2 points also. Okay, this is 0.1 percentage of carbon and this is 0.55 percentage of carbon, and we know this 0.18 percentage of carbon. Assume you have a percentage of carbon on this vertical line as 0.15 percentage of carbon. Okay, so understand this. So at point 1, so at 0.15 percentage of carbon and at point 1 you will have liquid phase. isn't it? You will have liquid phase at point 2, so at point 2, that is at 0.15 percentage of carbon, and a temperature which is between 1492 and 1540. In between this, somewhere at point 2, you will have delta plus liquid phase, isn't it? If you go by this, at point 3, between temperature that is 1400 and 1492, somewhere in between at point 3, that is at 0.15 percentage of carbon, you will have delta plus austenite. Similarly, at point 4, at this point, a temperature below this 1400, you will have austenite phase, that is so understand carefully, at a particular fixed percentage of carbon, if you change the temperature, you will have different phases. Listen carefully, that is peritectic reaction, eutectoid reaction and eutectic reaction. How these transformations are occurring, at what point they are occurring, and how to understand this. I will give you one trick here, okay, just a simple trick that by using that trick, it will be easy for you to understand the things. Okay, you have to search for this K. Okay, you have to search this K in your phase diagram, and the transformation will occur at that point, and this will be our point of interest. How? I will listen carefully, you will understand everything. So if you go by this, in this phase diagram, you can easily see a K here. This is ulta wala K, right? This is K, right? So and this is my point of interest. So this is where my transformation is going to occur. So you have several questions. So why you are calculating or why this is only the point of interest, why not this, or why not that? So this explanation requires almost 10 to 15 minutes, more 10 to 15 minutes. I will arrange a separate lecture on this, how exactly the transformation is occurring. For time being, we will just understand this trick that you have to find out K, and accordingly you have to take your point of interest where the transformation is occurring. Okay, cool. So what we are going to do here, again we are going to draw a vertical line at this point. Similarly, we are going to draw a vertical line here. Okay, so this is our first reaction. I will write down here in detail. So at 0.18 percentage of carbon, 0.18 percentage of carbon, and at 1492 degrees Celsius. This is important. At what carbon percentage and at what temperature? Now the transformation will occur here. How? See guys, in this region, at this point, that is point number 1 and this is point number 2, at this point number 1, you have delta plus liquid. So this delta ion plus liquid will transform into austenite. That's it. Simple. It is very simple. That is austenite. Simply this solid one plus liquid will give you what? Another solid, isn't it? And this reaction we called as peritectic reaction. This is our peritectic reaction. That's it. So what is peritectic reaction? A peritectic reaction, in general, a solid plus liquid will give you another solid, or a solid plus liquid will get transform into another solid at 0.18 percentage of carbon and 1492 degrees Celsius. That's it. This is the peritectic reaction. If you notice carefully, this is another K, right? This is your another K. Oh, cool. So again, I will draw a line here, and this is our point of interest, point number 1, point number 2. So second reaction, that is at 0.8 percentage of carbon and 727 degrees Celsius per point of interest. If you notice carefully, this is our another K, as I already shown you. This is your K, this is 1 point, and if you go by this is your second point, right? So, and this is my point of interest. So if I draw a vertical line here, this is point number 1, this is point number 2. This austenite will get transformed into, see, we have two ends of this K. Okay, this at this end you have alpha ferrite, that is alpha ferrite, plus this is Fe3C. Simply you will get alpha ferrite here. From this side this is alpha ferrite, and from this side this is Fe3C. So this region you will get alpha ferrite plus Fe3C, and combinedly we call this product as pearlite. Different people have different pronunciation. Few people call pearlite, few people call pearlite. We will have general discussion pearlite. Okay, so this is pearlite. Simply I can write in general way. This is a solid. So single solid, if single solid is transformed into another two solids, that is solid 1 and solid 2 and solid 3, and this reaction we called as eutectoid reaction. So you will have pearlite here. So this entire vertical line is of pearlite. Okay. So on this vertical line you will find pearlite. Don't get confused here. This is exactly at 0.8 percentage of carbon. So don't think that pearlite will be here also. This is pure pearlite will form on this vertical line because we have considered 0.8 percentage of carbon. So you will find pearlite on this vertical line. Okay, and this reaction is called as eutectoid reaction. Again, if you go by this, you will have another K here. You will have another K here like this. Okay, if I go by this is your vertical line. This is point number 1, point number 2. So at this point, that is point number 3, at 4.2 percentage of carbon, that is 4.2 percentage of carbon, and at 1150 degrees Celsius, this liquid will get converted into, now this is the region where you will get this austenite plus cementite. Okay, you will get austenite plus cementite, and we call this product as ledeburide. This is our ledeburide. So this is ledeburide. So again you will find ledeburide on this vertical line of 4.2 percentage of carbon right here. So this liquid is being transformed into solid 1 plus solid 2, and this entire reaction we called as eutectic reaction. Eutectic reaction, that's it. So if you notice carefully, this was our peritectic, this was our eutectoid, and this is our eutectic reaction. Now again another most important part, that if this line is if this line is pearlite and you have alpha ferrite on this region, so this intermediate region you will have alpha plus pearlite, isn't it? You will have alpha plus pearlite here. On this side you will have pearlite plus Fe3C, right? this perlite and this Fe3C, that is cementite, you will have perlite plus cementite on this side. Okay, one important thing, if you add percentage of carbon in iron, so after 2.1 you will have steel, after 2.1 you will have cast iron. And if you go by this is from up to 2.1 you will have steel, right? So one more term we used to recognize these two factors here. One more term we used to recognize these two phases as on this side you have hypoeutectoid. This side it is hypoeutectoid, and this side you have hypereutectide. This is hypoeutectoid, this is hypereutectide. And similarly, if you go by this is our ledeburite. So on this area, on this region, what we will have, this is the intermediate region where you have austenite plus ledeburite, isn't it? This will have austenite plus ledeburite, and on this region you will have ledeburite plus Fe3C. On this side you will have hypoeutectic, and on this side you will have hypereutectic. Now the most important part comes here. As we know, we have perlite plus Fe3C on the right side of this perlite, but also we have ledeburite here. So combinedly we call this product as perlite plus Fe3C plus transform ledeburite. Okay, combinedly we call this as transform ledeburite on this side. So entire this portion will be transform ledeburite. Okay, so I hope you have understood this phase diagram. This is very simple actually. I know this is very complex when you see first time, but if you understand step by step what actually we are trying to do, or what actually we are trying to understand from this phase diagram, it will be a very easy chapter for you guys. You do one thing here, you just pause the video and take a screenshot so that you will have entire phase diagram on in just one image. Okay, so you just take a screenshot here. Sorry, wait. Yeah, now you may take a screenshot. Okay, yeah, again I will give you another chance. Sorry. Okay, fine. So I hope you have understood everything now. A few terms that we have not discussed here, that is importantly why we have considered K and why only these 2 points will get transformed here. As I already said, we want a separate lecture for this, so I will have different lecture on how exactly this phase transformation is occurring, what exactly the lever rule and related concepts. So we will discuss in another lecture. So if you find any difficulty here, any single doubt here, just write down in comment box. I will try to answer as soon as possible. If you like this video, share with your friends, because sharing your knowledge is one of the easiest way to show some gratitude, show some care towards your friends. Subscribe to this channel and hit that bell icon so that you will get notified with our new lectures. Thank you so much.